There are several reasons. Operators have deployed heterogeneous networks, and now 5G networks are getting deployed as well. This brings about next realm of complexity for the operators when they're looking at really not only driving their network operations using network KPI-driven model, but really moving towards end customer experience-driven models. And that really enforces them to bring in the next level of automation into their networks. And that's where SON, with its optimization and automation engine, really becomes powerful for them to leverage.
So if you look at 5G networks that have been deployed today, it starts with an architecture called non-standalone architecture, which requires 5G and LTE to work together. And it takes a lot of operator effort to find the correct anchor cell for 5G that LTE can also be associated with. So we solve that problem through a feature called dual connectivity optimization. So we find the appropriate LTE cell, which already exists in the network that users are using today, with the new 5G cell that gets added. And this is done automatically by EdenNet, by our SON software. And this helps the operator save a lot of time in deploying these new 5G cells. In LTE, the standards provided a way in which neighbors could be automatically set up. But in 5G, the standards are behind the times. They have not defined it yet. So EdenNet has stepped in and provided an interim solution where these neighbor relationships between LTE and 5G and 5G to 5G can be automatically set up, again saving time for the operators. And we also have deployed already commercially many of the legacy use cases or well-known proven use cases like site creation, parameter consistency enforcement, PCI, code enforcement, conflict resolution, and so on. And we make the rollouts of 5G much smoother now compared to past technology introductions.
To add to that, electromagnetic frequency radiations are another important topic as well from a 5G deployment perspective, and we have significant module capability coming in as well from EdenNet to really help operators not only visualize their EMF radiations, but also how do they control that in the future. When I look at Tier 1 operators today, almost all of them across the globe have accepted SON and really started utilizing SON and its benefit in their networks. Of course, this has been the first step in a journey towards automation. They are now looking at ways in which they can institutionalize SON into their network operations and actually release people to focus on more service operations related topics as well. So we are in that first phase of the journey, moving from SON getting in with process automation, but then institutionalization is the next step. And this would mean taking in a lot more data sources into SON in order to really automate their processes in an end-to-end fashion.
So Yatin mentioned that the institutionalization of SON has been a journey for us. And we have had successes with many Tier 1 operators, but some of the smaller operators haven't been able to institutionalize SON as fast as the Tier 1 operators. And we want to help them have the same level of success as some of the leading operators in the world. We have about 90 plus deployments of EdenNet currently in the market. And the experiences have been, I would say, mixed between the different deployments. The problem we're trying to solve is to move from institutionalizing SON to democratizing SON, which means SON for all, or anybody can run SON in their networks. And that concept is what led us to cognitive SON. And cognitive SON basically takes the human expert out of the loop. So today SON requires a human expert who understands how the network is currently performing. He understands what areas of the network require improvement in KPIs. He understands which SON functions, use cases, or modules, as we call them, has to be run, and which part of the network it has to be run. He also has to determine how often he has to run those particular SON modules. With cognitive SON, that human element is taken over by by software, and we have machine learning-based techniques that automatically categorizes the network, attaches labels to every cell, so that the problems that each cell has is already determined by the software or using machine learning techniques. And the software also schedules these modules and runs them per that schedule automatically, and always watches for the benefits of these modules and how quickly we're moving towards an objective that the operator has set. So everything from the time you deploy the product to the time you achieve the benefits by meeting some of the objectives that the operator has set is completely automated. So that is what cognitive SON is all about. So if you look at how SON runs today, we have some limitations in how fast we can optimize the networks. The latency of data collection and the time it takes to perform actions is too long. We have to wait for 15-minute cycles of data collection. Probably it takes 1 to 2 hours to make changes to the network. And that does solve certain problems for our operators today, but it doesn't provide that near real-time type optimization that operators are expecting going forward. With the migration to CloudRAN, the data sets that we need become closer to the point in the network where SON is running. So today we have to collect the data through OSS systems, and with the migration to the cloud, the OSS systems, the eNodeBs, and the SON products are all running in the same cloud. So there is less latency involved in getting the data from the eNodeBs or from the OSS systems in order to perform our functions. So with that, we'll be able to provide what's called near real-time SON solutions. The other change that's happening in the industry as operators move to CloudRAN is a Open RAN initiative. They call it ORAN. And Open RAN is going to open up all the interfaces inside of the eNodeB. And it also provides an execution environment for SON to run inside the eNodeB or closer to the eNodeB. Open RAN calls it the RAN Intelligent Controller. They call it RIC for short. So we plan to implement EdenNet as microservices inside the RIC, and that RIC application will stay very close to the eNodeB. So we'll be moving from near real-time app to optimization solutions to closer to real-time optimization solutions. So CloudRAN is going to make data access faster, it's going to make our optimization loops faster, and it's going to move SON more and more towards the radio elements, the radio network elements. And we have termed a new name for it. We call it Edge SON. So traditionally you've had centralized SON and distributed SON, and with the migration to CloudRAN, we're introducing a new concept called Edge SON. So we have 3 layers of SON to deal with going forward. And these 3 layers will coordinate with each other, and the cognitive SON solutions we talked about earlier will work seamlessly across the 3 layers. So we're really excited to introduce that to the market and see our operators benefit from it.